Hello all, welcome to my channel and this is Karthik studying in Sri Venkateswara College of Engineering CSE AI domain. So today we'll discuss about typical RESnet architecture. So the introduction of RESnet architecture is given below. So the RESnet stands for Residual Neural Network. It was introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural networks effectively. So this is the introduction about ResNet architecture. So you can see the architecture of the ResNet over here. So the image source. So this is the introduction about ResNet architecture and the motivation for residual learning. So what is the motivational that is behind residual learning? Why should we learn residual learning? So the traditional deep neural networks suffer from vanishing gradient problem. So the traditional deep neural networks suffer a lot from vanishing gradient problem. Residual learning aims to address this issue by a shortcut connection. So we use residual learning to address this issue by connecting in a shortcut way. These shortcut connections allow the network to learn residual functions. So these shortcut functions allow the network to learn residual functions. So you can see the image over here. So and building blocks of ResNet. The basic building blocks of ResNet is the residual block. A residual block consists of two convolutional layers with a shortcut connection. The output of the shortcut connection is added to the output of the second convolutional layer. So the output of the one convolutional layer is connected to the output of the another second convolutional layer. This is the building blocks of ResNet. So on stacking residual blocks. So why do you stack this residual blocks one top of the other? So ResNet architecture typically stack multiple residual blocks. Deeper ResNet models have hundreds of layers. Stacking residual blocks allows the network to learn complex features. So we generally stack residual blocks to allow the network to learn complex features. This is a one main advantage of stacking the residual blocks. And the deeper ResNet models have hundreds of layers. So the deepest ResNet models have hundreds of layers in it. So that's why we stack one top of the other. So the ResNet architectures typically stack multiple residual blocks. So these typically stack multiple residual blocks. This is why we stack residual blocks and skip connections, shortcut methods. What are skip connections? Skip connections in ResNet allow the network to bypass one or more layers. So it can directly connect it to one layer, not to the neighboring layer, but to the some other layer other than the neighboring layer. So these connections are known as skip connections. Skip connections help with the gradient flow and available by the vanishing gradient problem. Skip connections enable the training of very deep networks. These are known as skip connections and residual learning concept. So in residual learning to the network learns residual functions instead of directly learning the desired underlying mapping. The residual function is the difference between the input and output blocks. The approach simplifies the learning process and improve performance. So on types of ResNet architectures, what are the different types of ResNet architectures involved? ResNet architectures come in different depths such as ResNet 18, ResNet 50, ResNet 101 and ResNet 152. Deeper ResNet models tend to have better performance but require more computational resources. It is a computational overhead. The choice of ResNet architecture depends upon the specific task and the dataset. Training ResNet models. How do we train ResNet models? Training ResNet models require a large dataset and significantly computational resources. Techniques such as data augmentation, batch normalization, and learning rate scheduling are the commonly used methods to train the ResNet models. Pre-trained ResNet models are available for transfer learning on new datasets. This is how we train the ResNet models and the benefits of using ResNet. So ResNet architectures have been widely adopted in various computer vision tasks. ResNet models have achieved state-of-art performance on image classification benchmarks. ResNet skip connections and the residual learning concept have influenced the design of other neural network architectures. These are the benefits of using ResNet, and the applications involved are image classification is a major application that is involved in ResNet. ResNet models are widely used for the image classification tasks such as identifying objects or scenes within images. They have achieved state of the art performance on benchmark datasets like ImageNet. So, object detection. ResNet serves as the backbone architecture for many object detection systems such as faster RCNN, YOLO, and SSD. The deep features learned by the ResNet are crucial for accurately localizing and classifying objects within the images. Transfer learning is also one of the major application involved in ResNet. Pre-trained ResNet models trained on large data sets like ImageNet are commonly used as a future extractors for transferring learning by fine-tuning these models on smaller domain-specific data sets. One can achieve good performance even with the limited labeled data. These are the applications of ResNet datasets, and the conclusion is ResNet architecture has revolutionized deep learning by enabling the training of very deep neural networks. The use of skip connections and residual learning has proven to be effective in improving gradient flow and learning performance. ResNet continues to be a popular choice for various computer vision tasks due to its performance and versatility. So this is the conclusion of ResNet architecture. So if you like my video, please like, share and subscribe. This is Karthik and signing off.